So today we are going to, I'm going to change this pink out of here. I wonder if I just go with a lighter pink. We're going to try that one. We'll try it. We are going to look at section 2.5, which is zeros of polynomial functions. So when we talk about finding these zeros, like what does that mean in mathematics when we have functions? Polynomial is just we have, you know, some more than one term in our little function. So when we're finding zeros of functions, like what does that actually mean? So remember when you would graph functions and you would find like where it would cross the x-axis? So I'm just saying it's crossing the x-axis at 3 spots. So who knows, maybe the graph looks something like this, right? So where this crosses the x-axis when my y value equals 0, that's what they mean by finding the zeros. Some, depending on like what section you're on or even in what math you're in, sometimes they call them zeros. The other name they'll call them is roots, is the other thing they'll call them. So that's what we're looking for. So we're going to have some nice little fancy polynomials, and then we need to know if we can find all of their roots. Sound good? All right. So there's this little theorem that we have that helps us out, and it's called the rational zero theorem. Oh, sorry, rational zero, because that's what we're finding, theorem. So when we were trying to find all of our possible zeros, and we want to know how many there are and like what they are, there's this little thing where you factor all of the constant terms. You come up with the factors for the constant term. And we'll go over this. It'll make probably a little bit more sense when we look at an example. But so factors of the constant term. And the constant term is usually always that last number, right, in our function, divided by the factors of the leading coefficient. So that leading coefficient is always that first number, right? Make sure your function's in highest to lowest degree, and then it's that first number that we have, right? So let's actually look at an example. So let's say we have, I'm going to try and fit it on this page. We're going to try. So I have f of x equals x to the third plus x squared minus 4x minus 4. Ooh, 4. I'm running out of ink, guys. I'm running out of ink. Out of 4. There we go. So when it comes to finding those possible rational roots, we're finding those, and it's not telling you that they are the roots, it's just telling you that these ones are possible. So you want to, remember it was the factors of the constant term over the factors of the leading term. So actually we're going to write it down here. So this here is my constant term, right? And then my leading coefficient is the number that's in front of my x to the third. And technically there's a 1 there, right? So this is my leading coefficient. So we need to find our factors of constant, just to save a little room, right? So our constant number is -4. So we have to figure out what is it you multiply in order to get -4. Well, you can do 1 times a -4. You can do a -1 times a positive 4, or you could do a positive 2 times a negative 2, right? And then now you need to figure out your factors of your leading coefficient. And our leading coefficient was 1. So how can we get 1? We can do a positive 1 times a positive 1, or we can do a negative 1 times a negative 1, right? And then if you want, you can even draw like a line so that you know like it's supposed to be like a fraction, I guess. Okay. So if we go through, you would have like 1 over 1, which is going to be 1. And we can technically either get a positive 1 or a negative 1. Okay. If we look at our 2, it would be like a 2 over the 1, which is 2. And either way, we can get that as a positive or a negative. So a positive or negative 2. And then the same thing happens with the 4, right? 4 over that 1, 4 over 1. Depending on which sign you're looking at, you can either get positive or negative 4, right? So, and then now you need to find the zeros. And to find the zeros, I think the easiest way to do it is to use synthetic division. Granted, if you're loving to use those long division, by all means go for some long division on this, but I like the synthetic division. Oops, I need to add some pages. Give me a second. One more. There we go. So to do synthetic division, you're going to look at all of these possible factors, and technically you have 6 possibilities, but with it being to the 3rd degree, no more than 3 of these are going to work. So half of them are going to work and the other half are not going to work. So it's really just by kind of chance when it comes to finding the first one. So out of all 6 of these, you're going to pick a number. And for poops and giggles, I'm just going to pick the positive 1. So when I do the synthetic division, that positive 1 is what's going to go in my box. And then I'm going to do just normal, typical synthetic division that we learned on Friday. So leading coefficient, that first one, that x to the 3rd has a 1, x to the squared has a 1, x has a negative 4, and my constant term is a 4. Okay. I'm going to draw a little line. I'm going to drop down that 1. 1 times 1 is 1. 1 plus 1 is 2. Right? 1 times 2 is 2. Negative 4 plus 2 is negative 2. 1 times negative 2 is going to give me a negative 2, and that's going to give me a negative 6. Right? So if we remember back when it came to finding remainders, this is technically my remainder. And so if I have a remainder, does it divide into there evenly? No. So that's telling me that that's not a factor. So I know that I can cross off. I need a red. Ooh, that red. I can cross off 1 as being a possible factor. So now we're going to pick another one. So let's go with, I don't know, let's try negative 1, right? So same concept. I'm going to put negative 1 in my box. Right, I got a 1, 1, a negative 4, and a negative 4. Drop down the 1. Negative 1 times 1 is negative 1, which is going to give me 0. Negative 1 times 0 is 0. It's going to drop down and give me a negative 4. Negative 1 times negative 4 is a positive 4, and I get 0 as my remainder. Because I have 0 as my remainder, I know that it divides into there evenly, so I know that it's a factor, right? So I know that one of my solutions, so I can write that up here, so I know that x is going to equal negative 1, and then I have possibly 2 more because that's x to the 3rd. So I'm going to write this out back into that standard form. So negative 4 is going to become my constant term. I lose, well, I'll write it for the first time, right? My x is going to have a coefficient of 0, right? And then this is going to give me my x to the squared term, right? Like 1x squared. So rewriting that nice and cleanly, you get what? X to the squared minus 4. And we're trying to find those zeros, so technically this whole thing equals, you want to find the zero, so this equals 0. And granted, you can go through and you can go, because you still have those 4 other options, right? You have -2, +2, -4, and +4. You can continue with the synthetic division and keep going with this and keep trying them until you find the ones that work. Or once I get to this point, I'm going, oh, look at that, I'm at a quadratic. And we know how to factor quadratics, don't we? And when we look at this one, this is a perfect square. Whoop. This is a perfect square. 4 is a perfect square. And our negative is a difference. So this is that difference of perfect squares. So we know that we can factor this into x and x. To get that negative number, it's got to be a positive and a negative. 4 times what's gonna, 4, you gotta find what multiplies to get to 4. That's gonna add up to 0. So we know it's a +2 and a -2, right? And those babies equal 0. Zero product property says x + 2 equals 0 or x - 2 equals 0. So we get x equals -2 and x equals 2. So then my other 2 solutions, you can even write it as a positive and -2. So now you have sat there and found all of the zeros for a 3rd degree polynomial. Look at that, guys. So let's go for one more. So let's say we have, making it a little bit more fancy, f of x equals 2x to the 3rd minus 5x squared plus x plus 2. Right? So to find my possibles, right, it's the factors of our constant term. So this guy is our constant term. So what can we multiply in order to get a 2? 1 times 2. And then you could either do, you know, a positive or a -1 and a positive and a -2, right? You can do -1 times -2 or +1 times +2. So we know we're going to get those. And then I need my factors of my leading coefficient. And my leading coefficient is 2. So again, I have a positive or a -1 or a positive or a -2. So then now I'm going to list out my factors. So I'm going to start with my 1 over 1, right? And I can either be positive or negative. So I'm going to have a positive or a -1. And then I'm just going to go with my 1 over this 2. Oh, so I got a half. And I either have a positive or a -half. Then I can switch over to this 2, so then I'd have 2 over this 1. 2, should wrote my 2. 2 over 1. 2 over 1 is going to give me 2. That's either going to be a positive or a -2, depending on which sign you're looking at. And then the last one, you would have 2 over 2. And what's 2 over 2? 1, right? Positive or -1. And we already have it listed, so you don't have to list it again. Whoop. Right? So then now I'm going to jump into that synthetic division. So I'm going to draw my little box. I'm already making sure, double check though, that we're in from highest to lowest, right? And that we have every degree covered. We got our 3rd degree, we got our 2nd degree, we got our 1st degree, technically we got our 0 degree, right? So we always want to make sure we have all of those covered. And if it's not there, remember to put that 0 in, right? So we have what? A 2, -5, a 1, and a 2, right? So now I just get to pick which value I want to use to do that first test. And I can use any of these 6, right? And I'm going to assume that this half is probably like the last thing you guys are going to try. So let's just look at the 1. Let's try a positive 1. Oop, how about I go to the ink? Positive 1, right? Draw on our little line. First thing we do is drop down our 2. 1 times 2 is 2. Negative 5 plus 2 is going to give us negative 3. 1 times negative 3 is negative 3. 1 minus that negative, or 1 minus 3 is going to give us negative 2. 1 times negative 2 is going to give us negative 2, which is going to give us 0. And that's what we want to see, right? We want to see that we get that remainder of 0 because that means that it is a factor, right? So then now I'm going to rewrite that. So my constant term would be negative 2. My next would be my x's. And if it helps, remember I even told you guys, like, throw your x and your x squareds in there, right? You can even just do it that way. It's going to give me my 3, and then my next term is going to be my x squared, which is going to be my 2. So I'm just going to rewrite it over to the right, just so that way we have a little bit more room to work on our factoring. Right? So 2x squared minus 3x minus 2. So then when it comes to factoring, you can use like that Xbox method, or you can jump straight to that area model even. So let's go with the little area model. It's like you're gonna do your x at the same time, kind of. So we know we have our 2x squared, and we know we have negative 2, and we just gotta figure in these x's, right? So when we're using the area model, right now we have 3 terms, and when we make this area of this rectangle, we now have 4 terms that we have to fill in. So we're looking at a way to separate that negative 3x into 2 separate x terms. So when we do our 2 times our negative 2, we get a negative 4. So for it to be negative, the only way you can multiply to get a negative is if one thing is positive and another thing is negative, right? So we got to multiply to get to 4. So we can go 2 times 2 or 1 times 4, and we got to get when we add these babies together, we have to get a negative 3. So we know that this one can't work. So it's got to be that 1 and that 4. Since it's a negative 3, we know that the 4 has got to be negative because it's farther from 0. And then this guy is going to give us our 1, right? And then now we just have to figure out what we're multiplying by in order to get our stuff in the inside, right? So I'm going to start with this guy, my 2x squared. To get my x squared, I know I have an x and an x to get the x squared. So now I have 2, so I have to figure out where I want to put my 2. I can go 2 times 1, right, and do it this way. Or I technically could put a 2 here and the 1 up here. So this is where you're just going to kind of think ahead a little bit. Because when I look at this 1x over here, if I put a 2 here, this is telling me 2 times what is going to get me to 1. And then now we're back to fractions, and we don't want fractions, right? So I don't want to put my 2 there. So where do I want to put my 2? I want to put my 2 up here and my 1 here. So I got my 2x squared. Whoops, that's like we're going to clean that up. A little 2 there, right? And now we can just kind of start moving around, figuring out our other parts to our factors. So 2x times what is going to get me to negative 4x? A negative 2, right? And then now I got to figure out this guy over here, right? So what times x is going to get me to 1x? A 1. And it's going to be a positive 1. So I like to throw the positives and negatives on there. So now I have 2x plus 1 is one factor, and x minus 2 is my other factor. I'm trying to find those zeros, so I know that, so I know that guy equals 0. Zero product property tells me one or the other has got to be 0. So either 2x plus 1 has to equal 0, or x minus 2 has to equal 0. Subtract 1 from both sides. 2x equals negative 1. Divide by 2. X equals negative 1/2. And this one we're going to add 2 to both sides, and we're going to get x equals, whoops, I guess I could finish the problem for you guys correctly. X equals 2. Right? And then we learned from this one, this guy right here, that's our other x. Right? And we also have, whoops, I don't want pink. Goes right over it. One of those days. And then we have x equals 1 is our third one, right? And so if you kind of go back through and you read all of those possibilities, we ended up getting 1, so that positive 1 was one of them. Lo and behold, guess what? That negative 1/2 was one of them. And then a positive 2 was the other one. So we actually got one of them out of each one of those positives or negatives. And then if you want, you guys actually, because these are a set of solutions, a set of zeros, you can also, when it comes to the answer, instead of writing it as x equals, and x equals, you can draw one of those little brackets. And I'm going to go from, I don't know, lowest to highest. Negative 1/2. 1 and 2. And then that is your final answer. You can write them that way as well.